Welcome to James Maths Academy. So in this class, I'm going to explain how to get the power series of this function using Maclaurin series. Okay. So the first thing first I want you to understand is for you to understand the general form of a Maclaurin series. So the general form of Maclaurin series must follow this equation. We all know that our f of x is essentially the same thing writing f of 0 plus first derivative f of 0 x over 1 factorial plus second derivative of f of 0, then we have x squared over 2 factorial plus uh, third derivative of f of 0 l is to power what? L is to power 3 factorial and so on and so forth. Okay, so it must be of this form first. So the second thing I want you to understand is for you to understand the unit cycle, because we're definitely going to work on the unit cycle. So in definition, if I so this let's assume that this is our unit cycle, and definitely you know that this 0 degree, this 90 degrees, this is 180 degrees, this is 270 degrees, and the coordinates will be 1 and 0, 0 and 1. This one should be 0 and minus 1. While this one should be minus 1 and 0. Okay, these are the coordinates. Okay. So we're going to work on dates of this unit cycle as well. The first thing first is for us to understand each of these functions and what it represents. Okay, so let's start with this function first. We're going to substitute it with what? With 0. So let's substitute 0 to x. So anytime you see x, put it as what? And substitute it with what? 0. So definitely this our cos and this sine. So sine is our y-axis, isn't it? So sine 0 plus this 0 degree, isn't it? So this is what is 0. Sine 0 is what is 0. So we're going to have our f of 0. It definitely was 0, because that is what the unit cycle says, isn't it? So let's look at the dy dx of sine. Dy dx of sine is cos. Okay, so our second derivative of our function is first cos s, isn't it? Because dy dx of our first derivative is what? Is cos. Okay, so if you substitute 0 in cos x, let's see what we have. If you substitute 0, you substitute 0 in cos x. So cos, the cos will be what? Will be as the s as is, isn't it? So this 0 degree, our cos 0 is what? Is 1, isn't it? So is 1. Okay, so our second derivative of this function is what? Is minus sine. Okay, our second derivative of this function is what? Minus sine. Okay, we're going to have minus sine, right? And if you substitute 0, in minus sine, you're essentially going to have 0. So minus 1 times 0, minus 1 times 0. This minus simply means minus 1, isn't it? So minus 1 times 0 is what? Is 0, right? So this is what? 0, right? Let's go to another one. A third derivative. What if you have third derivative of x? Third derivative of x, sine and dy dx of sine is what? Is cos, right? So cos minus times cos is minus cos, right? Minus cos x, right? So we have minus cos x, right? So if you have minus cos x, Um, if you are to substitute zero, zero for x, we're going to have 0 cos is at this side, so 0 times this minus means minus 1 times what? Times 0 times cos x is what? Cos x is 1. So you're going to have this minus means minus cos, um let's say cos 0 is what? Cos 0 is 1. So minus 1 times 1, minus 1 times 1 is equal to minus 1. Okay, we're going to have minus 1. Okay, so let's proceed. Let me add additional 2. So what of you have fourth derivative of x? We're essentially going to have this is let me put 0 here. We're essentially going to have s raised to power 4 raised to power 4 factorial plus let's have fifth derivative as well. S raised to power 5 over 5 factorial plus infinity. Okay, let's leave it like that. Okay, so let's do for our fourth factorial. In our fourth factorial, we're going to have f or of our function. So if this one is cos, the cos divide the s of cos definitely is a minus sign. So minus sign times minus, we're going to have plus sign. Okay, so we have plus sign x. So let's substitute 0 in let's substitute 0 for sign for x. So what do we have? We have plus sign 0. So sine 0 is what? 0 is y-axis, which is what? 0. Okay. So this is, we are left with what? With 0. So let's go to fifth derivative now. Let's see this fifth derivative. Let's see. Fifth derivative, this one is sine. Fifth derivative will be what? Cos. We're going to have cos x, right? So if I to substitute 0 into x cos 0, cos 0 is essentially 1, which is 1. So let's stop at this place. Okay, so let's rewrite what we does solve. So let me rule this line. Okay, let me recall back. Okay, I'm definitely going back to my initial formula. So our f of x will be our f of 0. Our f of 0 is definitely 0. I'm following this formula now. This is plus our first derivative of f of x. If you substitute it with 0, if you substitute it with 0, you're going to have 1. So it's going to be 1 times x over 1 factorial plus our second derivative. In our second derivative, we're going to have us our second derivative, if you substitute with 0, second derivative substitute with 0, we're going to have 0. So it's going to be 0 times s raised to power 2 raised to power 2 factorial plus our third derivative. Our third derivative is to substitute with 0, you're going to have minus 1. Okay, so you're going to essentially have minus 1 times s raised to power 3 raised to power 3 factorial. Okay, plus our fourth derivative. When you substitute with 0, you're going to have 0. So you're going to have 0 times x raised to the power 4 over 4 factorial plus our fifth derivative. When you substitute with 0, you're going to have 1. So you're going to be 1 times x raised to the power 5 x to the power 5 factorial plus dot. Okay, the three dots simply means what? It is what? Infinity. Okay, so you can keep going on and on and on and on. So let's solve what we have here. So this definitely 0. 1 times s is s. So we have s over 1 factorial. 0 times s raised to the power 2 is 0, so they don't need to write that one. So here we have minus 1 times s raised to the power 2 is same time writing minus s raised to the power 3 every to the power 3 factorial. Okay, and put this down very well. Okay, this one is 0. 0 times any raised to any times is 0. So here we have 1 times x to the power 5 there plus x to the power 5 over 5 factorial. Okay, so plus infinity, plus it keep moving on and on. Definitely you can guess which number will be here. Okay, so I want you to put that in your comment section. So for more informative content, don't forget to like, share and follow my channel, James Maths Academy. Once again, thank you.